Hello everyone, I welcome you all in this course Introduction to Sequence Stratigraphy, and we will continue our discussion on Lowstand Systems Tract. So, in the previous lecture we have discussed that what are the basic criteria of Lowstand Systems Tract, and we have seen that during the Lowstand Systems Tract we get deposition across the entire basin starting from the fluvial part into the marginal marine coastal area, delta, into the shelf and finally into the deep marine part. So, if I now try to understand the nature of processes in little bit more detail in these different areas, and as part of that already in the last class we have discussed about the low density turbidites that forms in the deep marine part. So, we will not go into that part again, but we can now look into the other part of the basin. Say for example, we can start with the fluvial system. So, what happens in the fluvial system during the LST phase? So, in this non-marine part, the fluvial part of the LST, we commonly get the deposition starting on the subaerial unconformity. Now, this subaerial unconformity, which is an erosional surface which is formed by some river downcutting, river incision process and some bypass zone where no sedimentation was going on, particularly in the interfluve areas. So, definitely when this LST its deposition is starting, it is getting a completely uneven topography, a very irregular topography, because somewhere it is highly downcut because of river incision, somewhere it is a interfluve relatively higher area, but no deposition is going on over there. So, when the LST will start, it will also show some sort of discontinuous geometry. We can expect that the LST will also show a discontinuous geometry, because as the base level is changing, the overall change with respect to water level across this uneven topography will not be same. And as a result of that, the amount of sediments or the nature of sediments which are deposited during the LST phase will vary significantly, particularly when we are looking into the fluvial component. So, there will be changes in terms of the sediment characters, there will be changes in thickness along the dip and along the strike. So, if we look into the low stand fluvial deposits, commonly we expect now the fluvial channels to amalgamate. So, that means fluvial channels will be filled up more easily, more quickly as the accommodation is increasing now. However, the accommodation is not that much that it will completely flood the entire channel and also its surrounding areas. Maybe locally in certain areas it may get flooded, in certain areas it may not get flooded. So, above the subaerial unconformity, what we get is certain channels which were incised earlier, they are now getting filled up with water, and definitely that water will supply huge amount of sediment within these channels. So, those channels will fill up by water and fill up by sediments. So, as the channel is getting filled up, there is a high energy flow is going on over there, channel will try to cut down again, or channel will erode in the side by areas and will get shifting of the channels, which is a characteristic of the braided river systems. So, there what we get, the channel systems will shift, again it will be filled up. So, subsequent channel fill deposits will overlay one another, which we call as amalgamated channel fills. So, within these incised channels which are now getting filled up and they are showing this kind of lateral shifting, they will show amalgamated channel fill deposits, amalgamated valley fill characters, and that will commonly show less amount of floodplain deposits, particularly when we are looking into the lower part of the LST. So, in the lower part of the LST, what is happening? Say if this was the river gradient at the end of the forced regressive condition. Now the base level at this particular position, definitely it was over here, and from this position it is going up. So for the first level of rise of the base level, the river profile has to change its position like this. So a channel, say if I consider a channel over here, which was earlier like this, where the water level was at this level. Now what is happening? Suddenly the water level is going up to this. So channel is filled up. However, the interflow area, which is lying like this, it is still not covered up. So this area is still having a gap in sedimentation. Maybe still there we are getting some sort of pedogenic processes going on, or maybe intermittently this area is getting flooded, having or depositing a thin floodplain deposit, and then again it is getting exposed during the no flood season. So as a result, we are getting a new horizon, maybe a thin horizon forming in the interflow areas now occasionally, where some floodplain deposits are getting deposited. So starting from this point to this point, or maybe when it is going further up, and if I consider this in 3 dimension across the dip, across the stripe, what we expect now? Say you have one such channel fill deposit, followed by another such channel fill deposit, followed by another channel fill deposit. So we get this kind of amalgamated channel fill deposits. So there is very less scope of deposition of these overbank deposits in between these channel fills. The sediment character, they are dominantly coarse sand. Coarser fractions of the sediment load available in that particular flow, they will be deposited within these channel fills. And we can get some overbanks, maybe somewhere deposited over here in this part, maybe somewhere preserved in this part, maybe somewhere preserved in this area. And these overbanks, they are dominantly mud, or sometimes they can be associated with some soil through pedogenic processes. So we can get either overbank mud deposit or soil deposits, but their abundances will be very less, particularly when we are looking at the early phase of the LST. So within these amalgamated channel fills, paleosols can be identified, can be recorded, which reflects syn depositional limited accommodation on the floodplains. So these paleosols, they are commonly immature, commonly we use the term wet paleosols, and may be associated with poorly developed coal seams, provided the coal forming conditions, the pit forming mires, they are fulfilled, they are forming, they are available over there. So presence of such paleosols or presence of such coal seams, intermittent coal seams, that indicates low rate of accommodation creation by this rising base level, which is coupled with high influx of clastic sediment. So in this scenario, what we are getting over here, the base level is rising up slowly. So by the time the base level is covering up this entire channel fill, it is also getting filled up by the sediments. So definitely the channel will shift, channel will migrate laterally, and we get this kind of amalgamated channel fill deposits. So in between certain gaps, in between certain channel fill amalgamations, we can get presence of these overbank deposits. The Lowstand fluvial strata, they commonly indicates sedimentation within the high energy braided rivers, as the overall gradient of the river is significantly high. So the steepening of the landscape gradient formed during the stages of base level fall is now getting filled up by water and by sediment. So definitely the supply of sediment is huge, and also the coarser grain sediments are available at more abundance. So definitely the river system will appear as a braided river system. So following the stage of the base level fall, when the most of the shelf becomes subaerially exposed, the LST phase may include self-edge deltas with diagnostic topset geometries. So, that is the part that we will discuss later on also in more detail, that what are the characteristics of the river forms forming in this delta plane. So, that is the part of the delta forming during the LST. So, overall whether we are looking into the fluvial part or whether we are looking into the delta plane part, which is forming more towards the self area, everywhere the river system will show the similar kind of character, as it will be a braided river in terms of the overall gradient available, which is getting rapidly filled up by sediments, and those sediments are mostly coarse grained sediments. So, when we look into the delta plane area, so over there, say if I look into the self edge, so now the river system has come down to this level through incision, and the river profile is showing a profile like this because of this incision process. Now, as the base level is rising up, this river profile is also showing a rising up pattern like this over here. So, overall the delta plane formation will be going on, delta plane aggradation will be going on, as this area is under wave and tide activity. So, what we get over here in this self area, the incised channels which are present in the self area, they are forming part of the delta plane, as they are getting affected by this marine tidal and wave processes. So, the river systems, they are getting huge amount of supply of sediments because of this higher gradient, because of this higher energy condition, and they are getting filled up with water. And those fluvial systems, they are getting affected, they are getting influenced by tidal processes. So, overall what we get is the aggradation, first of all formation of the delta plane, and that will gradually aggregate. That is the characteristic of the fluvial system changing over into the delta plane. So, if we move on to the more landward side, it is entirely the fluvial system. As we move on to the self, as we move on to the marine system, there we get the formation of the delta plane. So, due to this rise in the base level at the shoreline, the lowstand fluvial strata shows this aggradation with the formation of the delta plane area at the self edge, which extends upstream by onlapping the subaerial unconformity. If I look at over here, if this was the unconformity surface, on that when the base level is rising up, the first aggradation process of the river system will be something like this. So, we get extent of the river fill will be up to this point for the first level of rise. When the base level is rising over here at this point, the river water is further filled up, and we get the river fill deposit, channel fill deposit extending up to this point. So, it is occurring within the channel. If I draw a channel system like this, so if this is the channel section, so initially the channel was filled up to this. So, the channel water was filled up to this. So, we are getting the deposit forming over here within the channel. Now, the water level is rising up over here, which is resulting in further deposition of sediments up to this, and in that way when it will be third phase, it will further go inside. So, this is the onlap of the fluvial system, which we will observe in this delta plane area as well as in the fluvial part. In both these areas, we will see this onlap of the fluvial system, which is characteristic of Lowstand Systems Tract. Such onlapping fluvial system within an overall progradational pattern, within an overall regressive condition, is very distinct, very characteristic of Lowstand Systems Tract. So, as a result of this onlap, what we get is a wedge shaped prism that thins upstream. We commonly call it as the lowstand wedge or the lowstand prism, which is forming in the delta plane area, which is forming in the fluvial part as well, because of this aggradation, because of this onlap of the fluvial system. Coastal aggradation during the lowstand normal regressive phase, it also triggers a decrease in the slope gradient of the overall fluvial system as well as into the shore area, into the self area where the fluvial system has incised during the late phase of fall. So, in the downstream part of the fluvial system, which is more closer to the shoreline, present shoreline during the lowstand area, it will face a drastic change with respect to this gradient, because there the base level is rising and the river water has to adjust with respect to that base level position. So, there will be sudden change or rapid change in the river slope gradient. So, as the river slope gradient is changing, it is decreasing, it will induce a lowering in the fluvial energy with time. As gradually the low stand condition is progressing, we will get more decrease in the fluvial gradient system. So, when we are looking at a river system which was initially was here, so the flow which was going on over here will have more energy. Now, if the river gradient is changing like this, so the energy system of the river will decrease. So, this decreasing pattern in the river energy condition, that will be more prevalent in this area. It will be more prevalent in this area because this is more closer to the shore area, this is more closer to the shoreline condition where this effect of base level is very prominent. As we move inward, this effect will be relatively less, but there also the fluvial grade profile will try to adjust itself. So, such change in the slope gradient of the fluvial system results in gradual lowering in the fluvial energy, which further results in overall upward decrease in the grain size that is supplied within the deposits for these fluvial systems. So, within the fluvial part, fluvial component in LST, what we expect, the coarsest sands or coarsest fractions of the deposits to be deposited at the bottommost part, and gradually as we move upward within the fluvial onlap part, grain size will gradually decrease, which is related to the fluvial energy decrease, which is resulting in the gradual onlapping of the fluvial system, gradual adjustment of the fluvial graded profile with respect to rising base level position. So, at the initial part, what we were getting is mostly the channels, not much of overbanks. But as we move on to the more towards the late phase of the LST, where the accommodation is created at relatively higher rate now, the slope of the river system, the gradient of the river system is decreasing very rapidly now. So, that will lead to more frequent flooding, that will lead to more accommodation for flooding, and we will get more floodplains in between these amalgamated channel fills. So, in the previous diagram where we discussed about this channel amalgamation, channel fill amalgamation, there if we divide this as say part of the early phase of the LST. So, during this early LST, we have seen that the accommodation is created, but it is not sufficient enough to produce significant amount of floodplain deposits. So, there we can get some floodplain deposits, maybe some pedogenic process, some soil forming process in very local extent. So, what was the character over there? Mostly we are getting channel fills like this. These are deposited or filled up with coarse grain sands. So, this kind of multiple amalgamated channel fill deposits with little bit of fine grain sediments in between them as part of the overbanks which are occasionally deposited. Occasionally we are getting some floodplain conditions, because in this condition when this is going on, the overall base level is not rising at that much of rate and it is not creating sufficient amount of accommodation for the formation of floodplain deposits. But when we are reaching to the late phase of the LST, if I refer back to this base level curve, so now the gradient of the curve is changing slightly and the rate of rise of the base level is little bit more with respect to the start point, with respect to the onset of the low stand. So, now the rate of accommodation creation is more, and by the time the river system which was at this kind of slope at the early phase of LST, this has now reached over here. So, the river gradient has changed and this change in the river gradient has led to decrease in the river energy condition. Now during the LST phase, this river gradient is further changing like this. This is the river profile now. So the overall supply of sediments within the channels, it is restricted now. So we will get some amalgamated channels, but that is separated by relatively thicker overbank deposits. This kind of overbank deposits, and these are the channel fill sediments. So now what we get is frequent overbank deposits, more frequent with respect to this early LST phase, more frequent overbank deposits which are separating the channel fill deposits. Still we can get amalgamated channel fill deposits, but the extent of amalgamation or the intermittent overbank separators, that will be changing with respect to the early LST phase. So the preservation potential of this kind of channel systems, of this kind of overbank is to channel system, it will be very high, as this is going on in an overall increasing accommodation condition, and it will change over into the overlying transgressive part. During transgressive part, we expect that the underlying LST portion will be preserved. However, there is a deviation, there is a chance that some portion of the LST fluvial strata may get eroded, may get removed during the transgression event, as there can be certain erosion process can be associated with the transgressive process, transgressive system, which we call as the transgressive ravinement erosion. Already we discussed in our previous lectures about the transgressive ravinement surfaces, where we have seen that wave and tide ravinement processes goes on during the early phase of transgression. So in this kind of condition, when a transgressive ravinement is going on, which will be definitely restricted in certain part of the basin, it will not affect the entire basin. So in those portions where this ravinement process is going on, or maybe where the ravinement process is strong enough, it can remove some portion of the LST, and then this kind of fluvial deposits may not be preserved, may get eroded away. Where we can get this kind of deposits more prominently? Commonly when the transgression is going on over the fluvial system, we expect the fluvial system to get changed into an estuary system, and in the estuary mouth area, we expect the maximum amount of ravinement process going on by the effect of tide and wave. So those areas of the LST fluvial system which will be overlain by this outer estuary part, they can have a chance of getting eroded. But those areas where the central estuary deposits are formed, because the central estuary is relatively low energy condition and it is beyond the zone of ravinement process. So when LST part is overlain by the central estuary facies, which are commonly act as a buffer to protect the underlying fluvial strata from subsequent scouring, we can get the entire LST channel fill deposit to get preserved. So whether it is the early LST phase or whether it is the late LST phase, we can get preservation of these amalgamated channel fill and the associated overbank deposits. So in such conditions, what we expect is a very sharp change in the facies pattern. So the fluvial lowstand deposits, they are preserved between the subaerial unconformity at the bottom part, and at the upper part they are overlain by the earliest estuarine strata at the onset of transgression, particularly in the central estuary part. So if the underlying surface is the unconformity surface, where from this amalgamation of the channel fills are starting, so in this part we can expect maximum amount of channel amalgamations, like this with intermittent overbanks, and gradually as we move upward within the LST part, we get channel amalgamations which are separated by some overbanks. Now the overbanks, their portions are significantly increasing with intermittent again channel amalgamations, and then on this part we will get the central estuary deposits. If it is a wave dominated condition, this will be a lagunal mud dominantly. The central estuary part of the basin where we get dominantly fine grained sediments. Even if it is a tide dominated condition, there also we expect relatively finer grained sediments to be deposited in the central estuary part. So, this surface which demarcates this change is the maximum regressive surface, and definitely this surface is commonly a conformable surface, but it demarcates a sharp change in the facies, where the overlying facies is relatively finer grained, represented by this kind of central estuary deposits, and the underlying part is a fluvial channel amalgamation deposit. So, we commonly expect the fluvial low stand deposits preserved in this kind of conditions, where in the underlying part as the bottom surface we are getting the subaerial unconformity, whereas at the top part we get the earliest central estuary deposit, which marks the onset of transgression in that basin. So, in this kind of scenario we can get the best preservation of the LST fluvial deposits, where it has been covered by the estuary, but it is not affected by the ravinement processes. The contact between the low stand fluvial deposits and the overlying estuarine facies is the maximum regressive surface, and this surface is sharp. This surface is very distinct as it develops because of the formation of the estuarine system as soon as the shoreline starts its landward shift. Now, from the coastline, if we look into the seaward side, the shore face deposits which are forming during the LST, they are commonly gradationally based, as gradually the system is aggrading, base level is rising up. So, the energy condition is changing and we get successive gradationally based shore face deposits. Excepting for the earliest low stand shore face strata, which may be sharp based as they overlie the regressive surface of marine erosion which has formed during the forced regressive phase. Now, when we look into the further offshoreward direction in the basin, when we look beyond the fair weather wave base, the extent of the self facies may be significantly limited, because as the base level is rising up and it is gradually trying to cover up, trying to make this marine part more extended, but since there is more sediment supply into the system, the overall depositional conditions are prograding. So, there will be a chance that the overall extent of the self area is very much limited. So, the self facies will be limited due to the potential proximity of the shoreline to the self edge at the end of the forced regression. So, in such conditions, what we expect is the subtidal facies, they directly pass into the deep water slope facies, and they consist primarily of successive gravity flow deposits, or rather they trigger successive gravity flow deposits. So, if I look at the self edge, if this is the self edge condition where this was the base level condition at the end of the forced regression. Now, this base level is rising up. So, due to that rising base level, now we have extra amount of sediments are coming in. So, definitely the shoreline, it is shifting in this direction. The shoreline is shifting in this direction due to the accumulation of the sediments which are coming in over here, and they are accumulating in the form of delta plane and delta front. So, effectively what we are getting over here, if this is the last surface available for this much of rise of the base level. So, here we are getting a sudden break in the depositional condition. So, that sudden break will restrict the deposition of self-fall condition, because this is relatively high energy zone. We are getting the wave activities going on, here we are getting the tidal activities going on, as well as we are getting the longshore currents going on over here. So, as a result of these high energy reworkings, what we expect, the tidal currents or maybe the current systems which are available in this area, they will trigger supply of sediments along the slope and they will trigger the formation of successive gravity flows. They will produce the successive low density turbidites. They will produce the low density turbidity currents which will flow down the slope and reach over here in the basin floor to form the submarine fan system. So, that part already we have discussed in our previous lecture, how these submarine fan systems form, what are the nature of these low density turbidites. So, basically the disturbance, the kind of turbulence, high energy conditions which are prevailing in this area even during the LST phase, they are responsible for restricting the self deposits, restricting the extent of self conditions to prevail in the basin during the LST phase. They are responsible for triggering the low density turbidity currents and producing the low density sandy turbidites in the deep marine fan systems. So, in this particular lecture, we have tried to look into the other areas of the basin, starting from the fluvial to the marginal marine, forming a delta which is forming in the self edge area, and we have tried to understand what are the basic processes, what are the basic mechanisms in terms of change in the base level and change in the fluvial graded profile, and what are the responses with respect to aggradation or progradation of the different depositional systems. So, Lowstand Systems Tract, they are significantly different in terms of fluvial aggradation process, in terms of delta plane aggradation process, in terms of delta plane progradation process. When we compare that with respect to the HST or when we compare that with respect to the FSST conditions. We will continue our discussion on LST in our next lecture as well, where we will try to look into the other aspects of Lowstand Systems Tract, particularly with respect to the natural resources. For example, the petroleum occurrences, coal occurrences and other resources that can occur, that can be found within the LST deposits. So, these are some of the references that you can follow, that you can go through for further reading on this particular topic. Thank you everybody.